Next step is simply when we're doing our 6 trig functions, what happens if we get an irrational side? So I give you a point in the first quadrant like 2, 3. And so if we graph that over 2 up 3, about right there, there's my point 2 comma 3. So that would determine this angle in standard position. We'll call it beta this time. And so I need my x, my y, and my r so that I can do sine, cosine, tangents, cotangent, secant, and cosecant. Well, x is 2, no problem. Y is 3. R, I'm going to have to find by Pythagorean theorem, and this time it's not going to come out so nicely because I'm going to do 2 squared plus 3 squared equals r squared. So that's 4 plus 9, 13. So r is going to be the square root of 13. No big deal. We just start in doing our trig functions now like we were before. I'd say, okay, sine of theta is going to be y over r. That's 3 over the square root of 13. But now, like we've done in the past, for instance, when we were doing 30, 60, 90 triangle stuff, we can't leave this irrational number in the denominator. We need to do what we call rationalizing the denominator. So we multiply by root 13 over root 13, and we get 3 root 13 over 13. So that's really the only thing different than what we were just doing. It's just that now you might get these roots. If you end up with the root in the denominator, that's how we rationalize it to make that a rational number. If you only end up with a root in the numerator, as you'll see in a moment, we can just leave it there. Here we go, x over r. So x is 2, r is root 13. So I get 2 over the square root of 13. Same deal, can't leave my square root in the denominator. So I do that root over itself. I'm really just multiplying by 1. Anything over itself is 1. So I'm not changing the value of my answer, just the way it looks. So I get 2 times the square root of 13 over 13. Continuing on with tangent and cotangent, we're now doing y over x. That's just going to be 2 over 3. Nothing needs to be done there. X over y. Did I do that backwards? I did, didn't I? Y over x would have been 3 over 2. X over y is going to be 2 over 3. R over x, I'm getting root 13 over 2. Now my root's in the numerator. That's okay. I can just leave it there. That's all good. And then for cosecant, r over y, square root of 13 over 3. Again, that's fine. It's simplified. I don't have a root in the denominator. So if we're getting an r that's irrational here, no big deal. We just have to do a little work to simplify some of those to get that root out of the denominator.